Hello, dear learners. Today I welcome you for the lesson 5 that is related to the chapter number 3. In this, we are going to solve a worksheet in which chapter 3 questions are included, and you will be able to know about the structure of the questions and how to solve these questions. So, here is the first question. If you see here, Figure 1.1, the figure is given to you, shows the direction of four forces acting on a car as it travels in a horizontal straight line. The car is traveling in horizontal straight line and four forces are acting on it. Draw a line from each box on the left to the correct description of each force. If you see here, four forces are labeled here. Four forces are in different directions and four forces are present here in each box. So we have to match this with the correct option which is given here. Here description of the force is given. So force A is here, which is in the upward direction, and when we were discussing the types of forces, at that time we have discussed that there is a normal reaction force also, which is that there is when the two bodies or objects are in contact with each other, we have two forces, one in the downward direction and other one is in the upward direction. The force which is in the upward direction, that is basically a normal reaction force, or you can say a contact force. So this force A is going to be connected with this description. Similarly, one more force, force B is given. If you see here, force B is towards this direction. So if the car is moving towards this direction, then force B will be indicating as driving force. And as we know that if the force is in the downward direction, then there is a gravitational force or a force of gravity. So force C is indicating to force of gravity. Force D, as the car is moving in this direction towards the direction of force B, then in the opposite direction, air friction and frictional force is acting, air resistance is acting, so force D is indicating to air resistance and friction. Hope so it is clear to you that how these forces are going to be connect with the correct description. So in part B of question number 1, the table is given to you in which the sizes of forces, the magnitude of forces acting on a car at each time is given. Force A is 800 Newton. You can write here that force A is 8,000, I think, yes, 1000 Newton. And force B is 1000 Newton. Force B is here. Force C is 8,000 and force D is 600. Force D is 600 Newton and force C is 8,000 Newton. So we have written the forces, the magnitude or the sizes of forces to which direction they are acting. So what we have to do, the gravitational field strength is also given. So G is also given to you, and that is 10 Newton per kg. The mass of the car, mass we have to find here. What will be the mass? So what we have to do, we have to find the resultant force first. Or you, yes, we have to find the resultant force here also. But before resultant force, you can use this relationship that W is equal to mg. Why we are using this W is equal to mg? Because gravitational field strength is given to us and we have to calculate mass, and in this relationship mass is given. So then what will be the weight? Weight is a force. So what I will do, I will replace this W with force F, and I will write F is equal to mg. And this F is this gravity force due to gravity. Force C, which is acting in the downward direction. So it will be 8,000, which is given here, force C is equal to m multiplied by 10. So you can calculate from here that m is equal to 800 kilograms. So in this way you can calculate mass. This is the question 1b part, and further part is the first part. So the resultant force on the car. Now we have to calculate the resultant force. Forces are given to you. This force and this force having the same magnitude, but they are in opposite direction. So force A and force C will cancel out. We left with force B and force D. So for resultant force, you can do that it is equal to FB minus FD. FB is given, that is 1000 minus 600, and you will get resultant force, that is 400 Newton. So here we have first calculated mass, that was 800 kilogram, and then we have calculated resultant force, that is 400 Newton. And in the next part, the acceleration of the car we have to calculate. We know that F is equal to ma. We have calculated resultant force here, that is 400 Newton, and it is going to indicate this F. So F is 400 Newton. Mass also we have calculated, it is 800 multiplied by A. So now A is equal to 400 divided by 800. I have taken this 800 towards left hand side, and from here I can get 0.5 meter per second square. So this is your acceleration, which we have to calculate here in this part. After this we have question number 2. In this question, a car of mass 800 kilogram is being driven along a level road. So 800 kilogram is the mass of the car. The engine supplies forward force, that is 3600 Newton. So forward force is given, that is 3600 Newton, and I am representing forward force as Ff, and the total resistive force is also given, to which I say Fr is 2000 Newton. Now we have to first calculate the resultant force. So Fr is here representing to resultant force. Ff minus Fr gives me 1600 Newton. So this is the resultant force. So as I know that Newton's second law says that F is equal to ma, and this F is here basically the Fr is equal to ma. Fr I have calculated, that is 1600, is equal to m. Mass is given, that is 800, multiplied by acceleration a. So from here I get acceleration that is equal to 2 meter per second square. And this we have to calculate here. If you see here, what is the acceleration of the car? Hope so it is clear to you. Now here is the question number 3, which is also I think the last one. Yes, last question. A car moving along a horizontal road. The car has mass which is given to us. It is 800 kilograms. At one point in its motion, when the combined forces of air resistance and friction acting backwards are 400 Newton. So while moving in the motion, there is one point when the combined forces, that is air resistance and friction, acting in the backward direction. You can see here it is labeled air resistance and friction. It becomes 400. So I call these forces as F R equal to 400 Newton. Acceleration is given, that is 1.4 meter per second square. So we have to calculate here forward driving force. I indicate forward driving force as Fd, which we have to calculate here. So according to Newton's second law, that F is equal to ma, and here F is basically the total force, or you can say resultant force or net force, and we know that we have to calculate Fd, and from this Fd we have to subtract the combined forces also. Which one? That is air resistance and friction. So it is equal to 800, which is the mass, multiplied by 1.4, that is acceleration. So Fd is equal to, if you multiply 800 with 1.4, you will get some value, and I think it is, let me calculate it, it's 1120. And if I take this minus 400 on the other side, it will be plus 400, and you get from here 1520 Newton, which is the forward driving force which is required to accelerate the car. So this is all regarding today's lesson, and we have solved the worksheet related to the chapter, that is chapter 3, forces, and hope so it is clear to you. Thank you.